So hello guys, today we are going to check Coulomb's law of electrostatic force. So for that what we have done, we have taken two charges Q1, Q2, both of positive, and have kept separated from each other at a distance of r. Now what will happen, since they are of the same charges, so same charges, they repel each other, so they will have a force in opposite direction. Now from this topic, what Coulomb have identified, it has identified that force that has been experienced in this story was proportional, directly proportional to the product, to the magnitude of the product of the two charges, and force was inversely proportional to the square of the distance between them. So students, please understand whatever I said just now. You will find this statement everywhere. You can go through any videos, you will see that this is the only thing they are explaining. But today I am going to explain something different. The topic of proportionality does not talk about equality. Remember this point. I said, I have used this term, that force is directly proportional to the magnitude of the product of the masses. It's a very big story. It does not mean that the product of the charges. Now for example, one charge carries 2 coulomb, another charge carries 3 coulomb, right? So when you will say product of the charges, then you are going to have 6 what? If you're talking about 6 what? You are going to talk about the magnitude. Now does it mean that this 6 is the answer of this force? No. It is just telling you about the proportion. So for this, I'll make a separate video to make you understand about proportionality. Now let me make you understand that what does it mean, that when the square of the distance, means when the distance is increasing, the force between them is decreasing. This is what Coulombs have identified. From both these equations, they have concluded that F will be proportional to Q1 Q2 upon R square. Now we know that in order to remove the proportionality sign, I have to introduce a constant term. So I have used a constant term K. So what was K? The K's value was considered to be as 1 by 4 pi epsilon naught, whose value was 9 into 10 to the power 9. Please focus. 9 into 10 to the power 9 Newton meter square per Coulomb square. The value of this proportionality constant was in a very big magnitude. Now for this, what I have done, I have used the gravitational equation side by to this to make you understand more clearly. So in class 11 or class 9, we have got that force was directly proportional, or force was proportional to m1 m2 by d square or r square. So in that time, in order to remove the proportionality, I have used a constant which I have represented with capital G. Here the value of capital G is 6.67 into 10 to the power minus 11. Focus to the point, minus 11. Here we got 9 into 10 to the power 9, positive 9 Newton meter square per Coulomb square. This is the point to be focused. And here we got 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is the point to be focused. That's the reason we can find out from these values that electrostatic force is much stronger. Electrostatic force is much stronger than gravitational force. Got the idea?